Ladies and gentlemen, Software Incorporated is proud to present its heat balance calculation tool, AxCycle. AxCycle is intended for steady-state thermodynamic simulation and heat balance calculation of production of heat and electricity energy. Steam power plants are fossil or organic debris-fired and nuclear. Fossil-fired steam power plants will continue to contribute the most significant values of power supply. They form the basis of a working energy mix, which is indispensable to meet the major challenges of today and tomorrow. The scope of steam cycles that can be simulated in AxCycle includes cycles for fossil-fired subcritical and supercritical power plants. Fossil subcritical power plants. Historically, all steam power plants started as subcritical. Subcritical conditions are now used with legacy large power plants and continue to be used for mid and small-scale power plants. Fossil supercritical power plants. The run for efficiency increase imminently led to cycles with supercritical parameters. Supercritical power plants started from the middle of the 20th century with progresses on material properties. AxCycle provides a steam library suitable for subcritical and supercritical cycles simulation. Wet steam cycles for nuclear power plants. Due to specific conditions, nuclear power plants use cycles with lower steam parameters than fossil-fired plants. Nuclear cycles are operated in the saturated region mostly. AxCycle can also simulate wet steam cycles for nuclear power plants. The main problems of steam cycle simulation are: estimation turbine component performance, simulation extensive heat regeneration system, simulation the dependence of condenser inlet pressure on cooling loop parameters. Estimation of turbine component performance. Correct estimation of turbine performance can be done using aerodynamic solvers. Such solvers require to know a lot of data about flow path geometry, blade angles, and other. Such data as a rule are not available at cycle simulation phase. To solve this problem, AxCycle uses two simple and reliable approaches. First, turbine efficiency is estimated using well-known BCS Bailey-Spencer-Cotton method, or special map associated with component. Second, performance variation is estimated using so-named turbine constant, derived from Stedler works. Heat regeneration subsystem simulation. Modern steam cycles are featured with extensive heat regeneration subsystem. Thermal performance of cycle highly depends on optimal selection of extraction pressure and value. AxCycle provide means to study the influence of extraction parameters on cycle performance. Also, AxCycle provides feed water heated components with subcooling and underheating functionality. AxCycle provides feed water heated components with subcooling and underheating functionality. Estimation of turbine component performance. Correct estimation of turbine performance can be done using aerodynamic solvers. Such solvers require to know a lot of data about flow path geometry, blade angles, and other. Such data as a rule are not available at cycle simulation phase. AxCycle uses two simple and reliable approaches to estimate turbine performance. First, turbine efficiency is estimated according to well-known BCS Bailey-Spencer-Cotton method or special map associated with component. Second, performance variation is estimated using so-named turbine constant derived from Stedler works. The AxCycle Map multi-run tool is used to calculate the variations of cycle parameters' dependency on one or two variables by creating dependency maps. These maps can be visualized as 2D or 3D charts. The AxCycle Plan multi-run tool is based on a design of experiment method. It calculates the cycle performance dependency on the variations of multiple parameters. Plan uses a minimal number of cycle calculations in comparison with other multiparametric methods. Plan builds a multidimensional polynomial model which allows for a fast analysis of performance dependency to then perform its optimization without running additional AxCycle calculations. Plan results can be visualized as 2D charts and 3D surfaces. The AxCycle Quest is a multi-run tool which runs the given cycle by varying the values of a number of parameters. The parameters' values are randomly distributed within a user-defined ranges. The Quest tool is convenient to find the hidden dependency of performance on certain parameters. The Quest can be used to localize parameters' ranges of interest for further study with map or plan tools. The Quest tool results are presented as a cloud of solutions in a 3D space. AxCycle Case Multi-Run tool runs cycle calculation applying a set of parameters with user-defined values. Case tool is convenient to estimate performance in off-design operation mode. There is a sample of calculating of operational line of aircraft turbojet engine. AxCycle Delivery. AxCycle is available in online and desktop versions. For desktop version visit www.axcycle.com. For online version apply to sales@softinway.com. See AxCycle series movies. AxCycle for steam cycles. AxCycle for combined cycles. AxCycle for gas turbine engine cycles. AxCycle for organic Rankine cycles. Getting started with AxCycle. And others. Thanks for your time.